Hello everyone, good to see you again. In this video, the lecture about logistic regression, which is a statistical method to relate probability of an outcome to various predictors. Okay, are you ready? Then let's get started. We have learned two important concepts for CLM, lifetime value and LFM. An important managerial message from the lifetime value concept is that managers need to take an action to address who are continually profitable customers. Customer-centric firms are firms that focus on profitable customers in the long run and develop and execute marketing strategies to improve the long-run profitability by enhancing profit contributions from customers, improving customers' retention rate, and reducing costs incurred for customer acquisition. RFM provides a simple method to separate out profitable customers from the customer base. Recency, frequency, and monetary value are metrics that can be simply computed from transaction history data, but they are very powerful devices to find who will purchase more and spend more. Then, move our focus on marketing actions. Suppose that you are a marketing manager and designing a new promotion campaign. There are lots of options for promotion. You may offer extra membership points. A cash credit is a good alternative. And a price discount offer is a very traditional but still effective method of promotion. Those promotional efforts may change customers' responses. With a promotional offer, customers may purchase more and spend more. However, lifetime value and RFM do not directly address the effects of the promotions on future sales. In addition, what about customer characteristics? In various markets, it has long been proven that demographics and psychographics are good predictors of demand. Think about gender. My son always picks racing movies, but my daughter has zero interest in racing. How about income? High-income family may be more interested in premium offers than low-income family. Family size is another important demographic. If you have younger brothers, you may know that how much they eat and drink. A larger family may be more sensitive to deals on grocery shopping. Recency, frequency, and monetary value do not directly account for the difference driven by the characteristics. They just summarize the past transactions, and we can't know whether the characteristic difference changes RFM or not, and how much it changes RFM. So, in general, this question more directly tackles what CLM managers face in practice. What and to whom should we offer? For example, when you have two different options for promotional campaign, which one should you choose? Once you picked one, then to whom should you offer the promotion you picked? Logistic regression enables us to answer the question. Let me start with a conceptual example. Suppose that you can see the future. What would you do? You may buy lottery. You know the correct numbers to win Powerball. You know the correct timing to purchase and sell Bitcoins. You know which stocks you must buy for high return correctly. In consequence, you will get a jackpot. Now, imagine that there is a firm which can see what will happen. The firm knows likelihood that customers take each offer and knows the amount of profit coming from the customers accurately. Then, the firm must pick the best customers and offer the best offer to them to maximize profit. A logistic regression model is a tool for this prediction. Precisely, it is a model that relates probability of an outcome to predictors. In this example, the outcome is that the customers take the offer. Using various predictors, including the customer's characteristics and the features of the offer, the logistic regression computes the possibility that the outcome happens. Please note that it is not perfect, but given enough data of offers and customers, it can provide much better prediction than at least random choice. Then, how a logistic regression model provides prediction. It first analyzes past data to get some clues. For instance, let's say customer 1 had earned $120K and bought the firm's products 5 times last year, and she used the 10% discount coupon when it was offered. Customer 2 had earned $500K and bought the firm's product 3 times last year, and he didn't take any promotional offers. Customer 3 had earned only $80K and bought the firm's product 20 times last year, and she took a 20% discount coupon when it was offered. These are past data. From this, a logistic regression extracts clues about the relationships between purchase frequency and coupon usage, coupon discount rate and coupon usage, and income level and coupon usage as follows. The more purchases the customer had made last year, the more likely the customer used the coupon. The higher the discount coupon's rate was, the more likely the coupon was used. The lower the customer's income had been last year, the more likely the customer used the coupon. Then, the model makes predictions based on the clues. It's easy. Just change the tense of the clues. Then, the clues become predictions as follows. The more purchases the customer makes this year, the more likely the customers will use a coupon. The higher the discount coupon rate is, the more likely the coupon is used. The lower the customer's income is this year, the more likely the customer will use a coupon. The prediction directly indicates who to target for marketing activities. Let's look at the predictions. They describe the profiles of customers with high predicted probabilities. They describe who are the customers have 80% chance of taking an offer. Then, when we focus on those customers who match with the profiles, we expect better response rate and lower marketing costs to achieve marketing goals. Alright, now let me explain what is a logistic regression model. This is a basic grammar of a logistic regression model. It consists of 2 parts. One is a set of conditions, which are also called predictors, independent variables, or explanatory variable. The other is a binary outcome, or dependent variable. Here, binary means there are only 2 possibilities, like both sides of the coin. An example is that if a 10% discount coupon is offered to a high-income customer, she will take it. Another example is that if an extra 100K membership points is offered to a heavy user, she will sign up the membership. A logistic regression model provides the probability that the binary outcome happens. This is called predicted probability. For example, a logistic regression says there is a 70% chance that the customer will take it, or there is a 30% chance that the customer won't take it. But a logistic regression model is actually a mathematical model like this. It looks so complicated, but I'm going to explain each component, relating it to the verbal description. First, there are some X in the right-hand side. They are predictors. Second, the left-hand side stands for the binary outcome. Here, this PR means predicted probability that the outcome inside the brackets happens. And this probability is related to the predictors with coefficients or parameters. They capture how the probability is sensitive to the predictors. Lastly, this relationship is mathematically described by a complicated function which is called a logit function. For your better understanding, I'm going to explain the details of this mathematical expression with an example. Suppose that there is a company running an annual subscription-based business. This company recently introduced a premium service that provides premium benefits for the service, and during the last year, existing customers who were using the basic service were asked to upgrade. There were promotional flyers which were sent out to the customers several times. Marketing question is that this company wants to know who will sign up the premium service next year. To address the question, marketing managers of the company scraped data. For each customer, they gathered outcome denoted Y that indicates whether the customer finally signed up the premium service or not, annual income of the customer, denoted INC, based on the customer's report, usage history of the customer, denoted FLEQ, which is the number of purchases made, and promotional effort, denoted NMAIL, which is the number of flyers sent out to the customer. Please note that the types of the variables are different from each other. The income variable is a demographic variable like gender, age, family size, income and educational level, and the indicator of the place where the customer lives. The usage history, more precisely, frequency variable, is a past observation variable like RFM matrix, purchase amount, the brand the customer chose last time, the store the customer visited last time, and so forth. The promotional effort variable, NMAIL, is a decision variable like product or service features, price of the product or service, promotions, and sales or distributional channel types. The first two classes of the variables are mainly used for targeting. That is, we can profile customers who are highly likely to respond to our offers through those variables. So they are used to identify to whom we should offer. The other class of the variables is used for optimal design of a product or service. This is related to figure out what to offer. With these predictors, let's complete verbal descriptions. The focal product is the new premium service. So, the description should start with if the premium service is offered and to whom. Think about it by variable. First, income. So, if the service is offered to a high-income customer, then what happened? The outcome. In this example, customers choose one of these, sign up or not. So the description with respect to the income variable is, if the service is offered to a high-income customer, she is highly likely to sign up. In the same manner, we can complete the description for frequency variable and promotion variable. Now, translate the verbal descriptions to the mathematical formula. Here, the income, frequency, and promotion variables are predictors. So, they take axis places. Sign up is the outcome variable. Let's use 1 to indicate sign up for simplicity. And here are parameters. Each variable has its own parameter, which captures the sensitivity of the sign up probability to the variable. Please note that there is another parameter, which is called the baseline. This is not connected to any variable, it stands alone. This controls for how the service basically is attractive. If the baseline parameter is high, the service is attractive and sign-up probability is high in general, regardless of the customer characteristics and the service and promotion features. That is, even low-income customers, light users, and customers with little exposure to promotions are likely to sign up. If the baseline is low, the interpretation is reversed. The service is not that attractive. In general, customers are unlikely to sign up. That is, only high-income customers, heavy users, and customers with much exposure to promotions may sign up. And how to interpret the other parameters' values? Again, these parameters imply sensitivity. The higher the coefficient value, the more sensitive the probability. Here, I plotted the predicted probability over the size of income. All the other thing is equal. There is only one variation in the model. The income variable's coefficient value. Case 1, it is 0. Case 2, it is 1. Case 3, it is 5. If the coefficient is 0, then as in the first figure, the probability doesn't change as the income changes. That is, the probability is not sensitive to the income level at all. If the coefficient is 1, then the income variable now affects the probability. The higher the income, the higher the probability. If the coefficient is 5, then the sensitivity becomes higher. That is, the probability increment due to more income is much bigger than case 2, where the coefficient is 1. Now let's dive into the details of analysis with the logistic regression model. This is a basic procedure. First, we gather data and calibrate or estimate the logistic regression model. Second, interpretation. We interpret the result of the calibration. Third, we make our predictions based on the estimated model. Fourth, we do validation check. If necessary, hold-up validation is used. Last, we make our decision based on the result. Suppose that we successfully gathered data. Then, how to calibrate the model? That is, how can we know the values of the coefficient parameters? The coefficient parameters are the only thing we don't know. They are determined by these steps. First, we need to classify customers by predictor variable like high versus low income, high versus low frequency, and high versus low number of flyers sent out. Then, we can find the best coefficient values that generate the profile most accurately. This sounds like very complicated, but don't worry, we have software. SPSS or other software will do this calibration for you. Okay, this is a summary table of what would happen with various values of the parameters. First, let's talk about baseline parameter. If the baseline parameter value is equal to 0, then the sign-up probability is 50-50. If the baseline parameter value is low, in general, customers were unlikely to sign up. But if the baseline parameter is high, then in general, customers were likely to sign up. Next, income variable. If the coefficient of the income variable is 0, then sign up was irrelevant to the income level. If the value of the income variable's coefficient is low, it means that higher income customers were more likely to sign up. If its value is high, then higher income customers were much more likely to sign up. Then let's move on to the usage variable. If each coefficient value is equal to 0, it means that sign up was irrelevant to the past usage history. But each value is low, heavier users were more likely to sign up. But it is high, it means that heavier users were much more likely to sign up. Last, promotion variable. If the value of each coefficient is 0, it means that sign up was irrelevant to the promotional efforts. But its value is low, more exposed customers were more likely to sign up. If its value is high, then it means more exposed customers were much more likely to sign up. Then suppose that we observed the following patterns in data. For the baseline coefficient, we observed sign-up probability is 50-50. And for income variable, we found a pattern that higher income customers were more likely to sign up. And for the usage variable, we found that from the data, sign-up was irrelevant to the past usage history. And for the promotional efforts, we found that more exposed customers were much more likely to sign up. Then we can conclude that the baseline parameter is equal to 0 and the coefficient of the income variable is low and the coefficient of usage variable is equal to 0 and the coefficient of the promotional effort variable is high. If we observe different patterns, then the calibration changes like this. If we observe the pattern about the baseline coefficient, like in general, customers were likely to sign up. And for the income variable, we found that sign up was irrelevant to the income level. And from the data, we found that heavier users were much more likely to sign up. And we also found that sign up was irrelevant to the promotional efforts. Then we can conclude that the baseline parameter is high and the coefficient of the income variable is equal to 0, and the coefficient of the usage variable is high and the coefficient of the promotional effort is 0. Statistical software conducts the steps that I conceptually introduced and returns an estimation table. Here are lots of information, but we need to focus only on the B column and C column. B column gives estimated value of the parameters. C column gives corresponding p-values. The p-value measures whether the estimate is statistically different from 0. If this is smaller than 0.05, we can conclude that the corresponding variable is significantly different from 0. And this constant row indicates the baseline parameter, beta 0. And you may have one question at this point. Can a parameter be negative? In the estimation table, we have a negative baseline. What does the negative value mean? For the baseline, if the parameter is positive, the sign-up probability is greater than 50% in general. That is, basically, customers are likely to sign up. But if the parameter is negative, the sign-up probability is less than 50% in general. That is, basically, customers are unlikely to sign up. How about the coefficient of a variable? For example, what if beta INC is negative? If it is positive, high-income customers are more likely to sign up than low-income customers. But if it is negative, the relationship is reversed. Low-income customers are more likely to sign up than high-income customers. So, going back to the table, we conclude that, in general, customers are unlikely to sign up because beta 0 is negative. Higher income customers are more likely to sign up because the coefficient estimate of the income variable is positive. Customers who have more frequently purchased are more likely to sign up because the coefficient of the usage variable is positively estimated. Customers who received more flyers are more likely to sign up because the coefficient of the promotional effort is positively estimated. The next step is prediction. Suppose that we found the baseline coefficient is equal to -2 and the coefficient of the income variable is equal to 0.01 and the coefficient of the usage variable is equal to 0.15 and the coefficient of the promotional effort variable is equal to 0.21. Then the logistic regression becomes this. Given predictor variables, we can compute the predicted probability and draw the prediction if the customer signs up or not. For example, if a customer's income is 300K, frequency is 1, and M-mail is equal to 0, her predicted probability is 76%. That is, this customer is highly likely to sign up and predicted to sign up. But if a customer's income is $35K, frequency is 6, and M-mail is 1, her predicted probability is only 37%. That is, this customer is unlikely to sign up and predicted to not sign up. Then, how to compute the predicted probability? This is the logit function's formula. It looks so complicated, but it is not difficult to understand. Please look at the numerator. There is exp, which is a function widely used in math, physics, science, engineering, and economics. You don't need to know what it is exactly. Excel, SPSS, and R have a function to compute these. Instead, focus on what is in the denominator. The exp function appears again. That is, we need to first evaluate the exp function part, which is sometimes called odds or odd ratio. With the computed odds value, we can compute the probability. Then, we can make a prediction if the computed probability is greater than 50%, the customer is predicted to sign up. Here's an example. If there is a customer whose income is $300K, frequency is 1, and M-mail is 0. The odds is given by exp minus 2 plus 0.01 times 300 plus 0.15 times 1 plus 0.21 times 0, which is equal to 3.16. With this odds value, the probability becomes about 76%. That is, this customer is highly likely to sign up and predicted to sign up. Next, validation. Validation is a process to check whether a model or method works enough to actually use. Again, a logistic regression returns a probability and a binary outcome is predicted. Then, the validation condition is that the predicted outcome is the same as the actual outcome, that is, accurate predictions. There are so many measures, but these two measures have been widely used. One is misclassification rate, and the other is lift measure. Before diving into each measure in the next slide, please note that holdout validation technique can be used for logistic regression as well. Misclassification rate. Because the outcome is binary, only 4 cases are possible. First, the prediction is to sign up, and the actual is the sign up. This is a correct prediction. Second, the prediction is to sign up, but the actual is not. This means the prediction is different from the actual. Third, the same thing. The prediction is to not sign up, but the actual is. This is another case of incorrect prediction. Last, both prediction and the actual are the same as each other. So it is also a correct prediction. High accuracy means more correct predictions and less incorrect predictions. Misclassification rate is based on counting the 4 cases in prediction result. It is given by the number of incorrectly predicted cases divided by the total number of cases. For example, let's look at this table. the first row displays the number of cases where the actual is signed up, whereas the second row shows the number of cases where the actual is not signed up. The first column is the number of cases where the predicted is signed up, whereas the second column displays the number of cases where the predicted is not signed up. Then, these two diagonal cells show the number of correct prediction cases, and the off diagonal cells have the number of incorrect prediction. In total, there are 1,459 cases. Out of them, 56 plus 173, which is equal to 229 cases, are the incorrect predictions. Divide this number by the total number of cases, then we have the misclassification rate of 15.7%. Another validation measure is lift measure. Like RFM analysis, we can classify customers by the predicted probability. Look at this table. The customers are sorted by the predicted probability in descending order. Then, they are classified into three different groups. In the first group, Group 1, there are top 33% customers in terms of the predicted probability. In the second group, Group 2, there are the next 33% customers. And in the third group, Group 3, there are the last 33% customers. If the predicted probability is correct, more customers who actually signed up are classified into high group, and less customers who actually signed up are classified into low group. Then, counting customers who actually signed up in each group, we have this table. In each group, there are 100 individuals. That is, those groups are equally sized. In the first group, 92 out of 100 customers actually signed up. In the second group, 63 customers actually signed up, and 25 customers in the third group actually signed up. Then, accumulate this count from Group 1 to Group 3. Then, the cumulative sum up to the last group indicates the total number of customers who actually signed up. Here we have 180. Now, suppose that there is another classification, but all customers are classified just randomly. That is, the cumulative sum must be proportional. This figure plotted the cumulative sums for both cases. X-axis stands for the groups, and y-axis is the cumulated count. Blue curve is based on the logistic regression, and orange curve is based on the random classification. The orange curve shows linear as expected, and note that the blue curve is concave down. This is the sign that the logistic regression-based classification works well. If classification works perfect, all customers who signed up must be in Group 1 and Group 2. So the curve is more concave down, like this. The last step is decision making. Please recall what's the general C of M question. What and to whom should we offer? Now we can answer this question. First, to whom. This is related to targeting. The first two variables are customer characteristics, income and frequency. Their coefficients are positive, so our predictions are higher income customers are more likely to sign up, and customers who have more frequently purchased are more likely to sign up. Then, obviously, we need to target high-income customers and heavy users. Second, what? This is related to product, service, offer, or marketing activity design. For example, let's think about this specific question. How many times should the promotion flyer be sent out? This is also a question for design of marketing activity. For simplicity, suppose that the flyer will be sent out to all customers. That is, all customers received the flyer same times. Then, how to determine the optimal number of flyers to each customer? What if analysis? We can do simulation or prediction. What would happen if the flyer is not sent out at all, just once and twice? Based on the simulation, we can calculate the expected profit and pick the best number of flyers, which maximizes the profit. Alright, that's all I have in this lecture, and let me wrap up with a short summary. Logistic regression model is a model used to relate the probability of an outcome to various predictors. A CRM application of logistic regression is to address what and to whom a firm should offer. Using customer characteristics and past observations as predictors enables us to profile customers who are highly likely to take the firm's offer, and using decision variables as predictors allows for an efficient design of marketing actions. Misclassification rate and lift measure are used to validate logistic regression analysis.